average is a single number taken as the representative of a list of numbers. Consider an example. Let's say we need to find the average weight of 5 people. To make it fun, let's represent the weight using blocks. Let's assume each block has 10 kg. Now the person A is 40 kg, B is 70, C is 40, D is 60 and E is 40. Here the average or the single value to represent all the weight is 50 kg. We all know that this value can be found using the formula average value is equal to sum of the numbers in a set divided by number of items in the set. Similarly, how do you find the average value of a waveform? How to find the single value? To learn more about this, continue watching. Hi, this is Benila. I make videos based on electrical and electronics concepts. If you are into this, consider subscribing. Electrical waveforms are basically a graph that represents the variation of voltage or current over time. Now let's see what is the cycle and period of a waveform. If we consider the sine wave, the region between 0 to 2 pi is regularly repeated. Therefore, this region is called the cycle of the sine wave. Similarly, in the sawtooth waveform, the region between 0 to 2 seconds is regularly repeated. Therefore, this region is called the cycle of the sawtooth waveform. Time taken to complete one full cycle is called the period. Let's consider this waveform. The region between 0 to pi is the cycle of this waveform because this region is repeated regularly. The average value of each and every cycle in a waveform will be the same. Therefore, if we find the average of one cycle, that will be equal to the average of the whole waveform. So, it's enough to find the average of one cycle. Generally, finding the average of n numbers takes two steps, adding all the numbers in a set and then dividing it by the number of items in the set. Now, let's try to implement the same concept in our waveform. If we try to implement the first step, that is to add all the numbers in a set, then we have to add the current at each and every instant of the waveform in one cycle. Let the instantaneous current of this waveform be I1, I2, I3, I4 and so on till In. Therefore, the sum of instantaneous current is equal to I1 plus I2 plus I3 plus etc. plus In. Now, what about the second step? The number of items in the set here refers to the number of instantaneous current we are considering. Since it's from I1 to In, the number of instantaneous current we are considering is N. Therefore, the average value can be written as I1 plus I2 plus I3 plus etc. plus In divided by N. Now let's see how to find this N. The current at this instant will be equal to the height of the waveform at this instant. Therefore, the instantaneous current at this instant is I10. Similarly, the current at any instant will be equal to the height of the waveform at that instant. Now, if we consider this omega t axis, we can see that there are n number of instants in one cycle. We also know that this region is called the period of the waveform. Now, let's assume that dx be the distance or gap between two instants. Now, it's very clear that period of the waveform has n number of dx in that. Therefore, mathematically, period can be expressed as n into dx. From this, we can find n as period divided by dx. Now, if we substitute this n in our average formula, we get the average as sum of instantaneous current into dx divided by period. We can expand this as I1 dx plus I2 dx plus etc. plus In dx divided by period. Now, let's consider this rectangle. Here, the height is I9 and the base is dx. Therefore, I9 into dx will give the area of this rectangle. Similarly, I1 into dx, I2 into dx, I3 into dx and so on are all the areas of small rectangles in this cycle. If we add all these small areas, we will get the total area covered by the waveform in one cycle. Therefore, the average value is equal to total area covered by the waveform in one cycle divided by the period of the waveform. For easy understanding, let's consider this waveform. In this waveform, the region between 0 to 2 seconds is repeated regularly. Therefore, This region is called the cycle of this waveform. Therefore, the period of this waveform is 2. Now, we have to find the total area covered by this waveform in one cycle. We know that the area of the triangle is half into base into height. In this case, base is 2 and height is 2. Therefore, the area covered in one cycle is 2. If we substitute this in our average formula, we'll get the average current value as 1 amp. Now let's see this example. In this waveform, the region between 0 to pi is repeated regularly. Therefore, this region is called the cycle of this waveform. Now, how to find the area under this curve? We may get an approximate area if we consider this as a triangle. But how to find an accurate value? Do you have any idea? In mathematics, we have an amazing concept called integration. We can find the area under any curve through integration. The formula for the area over the interval a to b is integral a to b f of x dx. Here, the interval a to b is the cycle of the waveform. Therefore, we can find a period using the formula b minus a. If we substitute this in our average formula, we'll get a simplified formula for the average value. Therefore, the average value of any waveform can be calculated if we know the function of that waveform. To know more about the f of x of any waveform, check out my video on mathematical function of different waveforms. I'll post the link to the video in the description box below. In this case, f of omega t is Vm sin omega t for the interval 0 to pi. Applying this in our formula and integrating it will give us the average value as 2 by pi. Now let's see this example. This is the same problem that we solved earlier using the triangle area formula. Now let's solve this using integration. First, let's find f of x of the waveform. It is very clear that the function is a straight line over the period 0 to 2. Therefore, f of x is equal to mx plus c. The coordinate point in this straight line is 0, 0 and 2, 2. We know that the slope m is equal to y2 minus y1 divided by x2 minus x1. Therefore, m is equal to 1. Here, the y-intercept c is equal to 0. Therefore, f of x is equal to x. Applying this in our formula and integrating will give us the average current as 1 amp. The RMS value of different waveform will be discussed in my next video. If you are interested, don't forget to subscribe and click the bell icon so that you will be notified each time I upload a video.